Greetings, fellow colleagues and purveyors of excellence in educational practices. This is Dr. Izad with another video on the matter, and the focus of this one is geared toward mathematics instruction in the earlier grades. Now, when it comes to math, proficiency and interest in the topic tends to taper off after the 5th grade, as I mentioned in my TEDx, linked here in the card. You can check it out for full context. Suffice it to say, this phenomenon can be attributed to lack of conceptual understanding of mathematics concepts. That is to say, math is often taught outside of the contexts in which it is applicable and in which said concepts were either created or discovered, and this is increasingly true as students enter the realm of more abstract math concepts. In essence, this leads to lack of desire to explore this domain of knowledge, as the concepts don't seem useful, and the lack of proficiency stems from the fact that math resultantly becomes a series of inexplicable steps to memorize. To this, some might say, but math is happening everywhere all the time, so how can they not see the relevance? To this, I say, relevance is different from utility. And though math may be happening or may be used to describe everyday innocuous activities, no one is using complex math concepts or engaging in any complex computational thinking that is involved in math when participating in those activities. For instance, no one needs to calculate the area of a bed before sleeping in it, nor does anyone need to understand any complex geometry to have a door frame that accommodates one's height. And sure, when people are throwing around a ball, they are engaged in an activity that suggests that space-time is curved, and mathematical calculations can be used to prove this notion, but no awareness or understanding of a gravitational force that permeates all of space and time is needed to be able to throw a ball around, nor does anyone need to perform those calculations for the ball to do what it does on its own when thrown. The only time when someone would need to understand those concepts are when the aim is to put man on the moon or launch a laboratory into space that will orbit the Earth as long as it maintains a certain velocity. The point being that math, as well as anything that ought to be taught in schools, does not have much in the way of utility with respect to typical day-to-day activities, nor should it. Math, especially the more complex concepts, deals in a domain of knowledge that is used in very specific contexts that are career-related, no less, and when such concepts are being taught, they should not be divorced from their applications. And though some of the examples of some of the contexts that I provided in which math can be utilized pertain to the later grades, contextualization of more rudimentary skills can take place in the earlier grades. And such contextualization can be conducive to building hard computing and technical skills, and I made mention of this in my TED Talk when I introduced the Scratch platform. Today, with platforms such as Scratch, such a replication of these contexts is made possible. For those of you who don't know what Scratch is an online community in which individuals are able to create and share interactive media. And the interactive media that they're creating may take the form of an animation, or it may take the form of a game. And the way that those animations and games are created is by using a block-based coding language that will look a little something like this. Now, what you have here... What I was describing there was an idea for a project and an exemplar thereof that would allow students to apply knowledge of mathematics concepts by creating a game. In this case, a game of Pong, using the coding language presented in the Scratch platform. And these learning standards are among some of the common core mathematics standards that are addressed, and I'll explain how as I model for you how I created this game. In order to create anything on Scratch, you must first understand that Scratch takes coding languages like C# and Python and takes the different arguments and syntactical structure of those text-based coding languages and places them into relatively easy-to-read blocks, which can snap together if the segments of code are properly construed. And on the left side here, underneath the Code tab, you have these blocks of code that will regulate different dynamics of each of your sprites. Sprites referring to two-dimensional renders of different objects in the scene of your game. You have blocks of code that regulate motion, the appearance of the sprites, sounds that can be triggered upon certain conditions being met, events like what your sprites will do when a button is clicked, control, which refers to the conditions that precipitate or cause other events, sensing, referring to the sprites coming into contact with one another, and some things repeat a bit. And in my completed Pong game, you'll see that I have several sprites: the ball, the paddle, and two tanks. And the ball interacts with each of the other sprites, and the way that the sprites interact with each other are often expressed in mathematical terms, and thus, conceptual understanding of math is required and promoted. For instance, look at this block of code that I applied to the ball. The go-to portion of this block refers to where I wanted the ball to appear on the two-dimensional plane, and that would require conceptual understanding of graphing, making this 5th grade standard applicable, as students would have to understand that 0 on the x and 0 on the y would place the ball at the very center of the screen, and where they want the ball to be positioned will have to be expressed in relation to that. Moreover, knowledge of acute and obtuse angles, and angles in general, are applied here, as the ball will not be stationary when the game begins. I wanted the ball to move in a straight path along the direction in which it is pointed, and it is pointed 45 degrees from its origin point. That is why the ball moves as such. Now see what happens if I change that value to 90 degrees. And you'll see the same mathematics principles being applied to the code that governs the movement of the ball when it comes into contact with other sprites, like the tanks and the paddle. And even in the health bars attached to the tanks, knowledge of more rudimentary math concepts are applied, like understanding what negative integers represent in relation to a given starting point, making this platform perfect for PBLs for a variety of grade levels, ranging from 1st grade to 8th. We shall review the nature of the coding process and the computational thinking that underlies the process right now, as I show you how to create such a game, should you choose to model a project like this for your students. So when you go to File and click New, you'll get an interface that looks like this, and you'll want to add a sprite for the ball. You can custom make your own and upload a file, or you can choose an existing sprite from the platform. For the ball and the paddle, we'll choose an existing sprite, and you can drag and drop to position them, or input the desired coordinates on which you want each sprite to be placed. And you may have noticed that the backdrop of my game is from the Metal Gear series, and you can add a backdrop from a file from your computer by clicking on the Backdrops tab, going to the Uploads option, and uploading a file. For my game, I took a screenshot of a Metal Gear game and uploaded that. Now, I also want the tanks to be interactive sprites, so what I did was I took a picture of both tanks and uploaded them as sprites as well. And then I simply placed them over the two existing tanks in the backdrop after adjusting them to the desired size. And I'm also going to create sprites for the different boundaries that the ball can come into contact with, as we don't want the ball to fly off the stage outside the parameters of the backdrop. So we're going to select the line sprite and use those as the walls, so the ball can bounce back if it touches the edge of the backdrop, and so the game can stop if the ball touches the dead zone. So you'll want to choose the line sprite and then duplicate it, and you can name one wall, and the other wall 2, and name another the dead zone, and adjust the size of each here, and place each in the appropriate spot, applying your knowledge of angles to adjust the positioning of some of them. And now to write the code for each of the sprites to make the game play as such. And for the purposes of this video, I will only be explicitly going over the code that pertains to math concepts. Everything with the sounds and costumes that I apply to the sprites, you can figure out by looking at the code I displayed from the completed game previously, and by tinkering a bit. So if we want to apply code to the ball, we will first have to have that sprite clicked. And then we will scroll down to the events, and we will click on this block and drag it over here, because we want this script to run when the flag is clicked to start the game. Then we will go to the motion blocks and drag this one over and connect it to the first block to place the ball in the desired location on the coordinate plane, which pertains to that 5th grade Common Core math standard that I presented before. And this block will indicate in what direction the ball will initially travel. And notice how all of the blocks are shaped a certain way. This lets you know if the syntax of the code you are writing is correct and eliminates room for compiling errors, as the blocks will not connect if the structure is not correct. Now we want to drag this block over from the control blocks, and this is because we want whatever arguments are nested inside this block to happen as long as the game is playing. And this bit is probably unnecessary because I created borders, but this is just telling the program to make the ball bounce off the edges and move a designated number of steps. But our ball will never touch the edge because the backdrop was not fit to the entire stage, which probably would have been a better move, but whatever. Now let's see how we can apply this to the different sprites and use knowledge of mathematics concepts to make the game appropriately challenging. So I'm going to drag these two blocks over here again, once more because I want the script to run as soon as the flag is clicked, and I want this to happen continuously after the flag is clicked. And then choose an if-then statement from control. I'm then going to go to the sensing menu because I want the ball to do a particular thing when the game senses that the ball has come into contact with another sprite. So I'm going to choose the touching block and select the appropriate sprite from the drop-down. All of the sprites we created will be listed here. So if this condition is met, I want the motion of the ball to be impacted. So I'm going to go here and select this block because I want the ball to then move in the other direction. But in order to make the game challenging, I don't want it to move along a single fixed path every single time. So I'm going to insert this from the operators because I want the movement of the ball to be random. And since I want the movement of the ball to be unpredictable, I'm going to want it to move in any direction in the opposite direction within the scope of a right angle. Which this is not, but I fix that later. And because I want the ball to do this when coming into contact with multiple sprites, such as the walls and the tanks, what I'll do is I'll duplicate this code by copying and pasting it, and selecting another sprite from the drop-down menu in that sensing block within the if-then statement. And I'll do the same for the dead zone, but instead of connecting the turn block from the motion menu, we'll select stop all from control, and this will designate that the player lost the game of Pong. And notice how the ball is moving. That is because the code is still set as such. And if I change it to 180 to 90 degrees, notice how the movement of the ball is more conducive to the game's intended dynamics. And now for the paddle. We will follow the same initial steps with the events block and the forever control block. And we are going to select this from the motion blocks and place mouse X from the sensing tab because we want the paddle to follow the motion of the mouse. And we're going to do this to end the game when the space button is pressed. Now for the health bar for the tanks, in which this standard can also be applied. Say if one of the assignment parameters was to create a game dynamic in which the energy bar would be decreased to 0 after X number of hits. So I'm going to do the same thing with the events block, Then I'm going to select this block to set one variable to a particular value. And in order for this to work, we will have to create a variable. And we are going to name it health and select that variable from the drop down here, and then set the value to 100. Now we want to have another if-then statement nested within the forever block and drag this from the sense blocks as we want the health bar of the tank to change by -10 units each time it touches the ball. And now let's see what happens. And we will repeat this for the second tank. And now we have a functional Pong game in which mathematics concepts were used to create the game dynamics. Among those concepts were concepts pertaining to fifth grade geometry, as students would have to apply knowledge of coordinates and two-dimensional coordinate planes in order to manipulate the movement of the sprites. Standards that pertain to number and operations in base 10 for grade 4, as students may utilize those principles to create a system through which the tanks will lose health, and grade 7 standards for the number system, as students will express how much health is lost by applying knowledge of negative integers and how they represent changes relevant to a given position. And many other standards can be applied through game design, through use of Scratch, depending on the nature of the assignment, thereby allowing students to apply content-related knowledge while developing technical skills, which, taken together, can eventually be turned into lucrative careers. That, after all, should be the purpose of school: preparing students for the various careers and introducing them to career prospects. Many students leave compulsory schooling with no idea as to what their career prospects are, but introducing activities such as this in the primary grades can be a huge step in changing that reality.